I had a question about this one. This is 28.3 from the text, and I believe my numbers are that we're given a 6-volt battery and it's hooked up to a circuit like this, and they want to know the voltage difference between 1 and 2. So let's just call that the voltage difference, just show like the magnitude of that. And so the key here, and this is a tricky subject, we spent some time in lecture talking about this, is that basically this circuit is not hooked up. And so there will not be any steady state current in this circuit. Basically, these are two conductors hooked up to the two ends of this battery, and they're going to very quickly reach electrostatic equilibrium. What do we know about electrostatic equilibrium? We know that number one, the electric field inside will be 0, and if the electric field is 0, that means the potential has to be constant. And so let's just pick numbers, and let's say, again, my numbers are 6 volts. I'm not sure what yours are, so that means that the top of the battery is 6 volts, say, and the bottom is 0 volts. Of course, it doesn't have to be that way, but let's just make it that way to make life easy. And so what this means for us is that every piece of this top part here, remember this top part is a bunch of wires, it's a resistor, but it's all just metals. It's all a bunch of free electrons. And the electrons are going to move until the point that there's no advantage to move. And that point is when the whole wire becomes a potential of 6 volts. Right? Once it's 6 volts, then if you're an electron over here, there's no reason for you to move anywhere because you can't get to a more advantageous potential because it's just all the same. And by the same token, down here, you'll very quickly reach the point where every piece on this wire, which again is just a piece of metal, will come to 0 volts. And so the absolute value of the difference there will turn out to be the same 6 volts. All right, and it has to do again with conductors and electrostatic equilibrium.